There we go. Well, I guess we're ready to go. So thanks to all of you kids for coming out. This is a real treat to be here. You are the first classroom that gets to take part in the Everest Education Expedition. Just by luck, you happen to be a Frisbee's toss away from Montana State University, and that's where we're starting everything for our big expedition there. I'm working with Dr. Dave Lageson, who is a structural geologist in the Earth Sciences program, and Travis Courthouse is a graduate student in structural geology. And so we're going to be going to Mount Everest and studying this mountain and sharing our experiences of being on the mountain with all of you. And hopefully, as we go along, there will be 8 weeks where you'll be able to track us, that you get to learn amazing things about our planet, about Earth sciences, about the atmosphere, human physiology, and that above all of that, you get really excited for science. And why would you want to get excited for science? Come on, someone, okay.
For hovercrafts.
For hovercrafts, I like that. So that's having a connection to something in science that gives you a reason to learn more about science, and whether it's hovercrafts, geology, the atmosphere, robots, biochemistry, field biology, anything like that that relates to science. It's a great way to go, because you're at this point in your life where you're able to really make a difference in what you do as life goes forward. So I'm going to be standing back here. For those of you that are directly in the line where I'm blocking, you might want to just scoot to one side or the other, because I'll be standing here as I talk. Does everyone hear me okay?
Yes.
Okay, this is Mount Everest, and as we look at it, it's a pretty interesting mountain, and it kind of looks like a layered cake. Any ideas why it looks that way? Well, we're going to go with this young lady over here, please.
It's because, like, the rocks have been layered.
Exactly. It's strata. So what we're going to be doing here is we're going to look at that top bit of Mount Everest, the Chomolungma Detachment, and understand why it's where it is and how it got there. And Dave's going to be conducting a geologic profile, so he'll descend the mountain, and every 100 meters in closer intervals at contact zones, he'll be taking a sample of rock. We'll bring that back here to Montana State University, and we're going to take a look at that rock from the big picture, like we see here, all the way down to a microscope electron type level. So we've got a real fascinating way of doing that. But Everest goes back to about 80 years ago, and this is one of the pioneering English climbers, George Mallory, who set out to climb Everest in 1924. And their expedition, like ours, had a scientific basis to it. And they were up there. Noel Odell was a scientist, and their big goal was to look for fossils on Mount Everest. And they were able to find fossils in 1924 at an elevation of 8,300 meters, which translates approximately to 27,500 feet. Pretty fascinating stuff. And we can see what expeditions looked like in the 1920s. Here they are. They had button-down jackets, they would wear ties, they had felt boots, and of course things are quite a bit different now. And this was the climbing team as they were there. They were climbing in from the Tibet side to the northeast ridge, the same route that I had climbed in 1999 and again in 2007. And we can see here Sandy Irvin working on the oxygen apparatus. And so you had a steel cylinder with bathtub fittings and a rubber hose to give you supplemental oxygen. Any idea why we would want supplemental oxygen at altitude? Please.
Because the higher up that you get, the air pressure gets lighter.
Is less air pressure. Great answer. And the analogy that we use is like, so if you fill a balloon up and it's confined, all the oxygen molecules will be put close together. But if you have a balloon that's really elastic, they go further apart. So there's not any less oxygen. They're just being forced together at a lesser rate, and that's because the atmosphere has an effect of compressing the air. So when we're at sea level, we have 100% oxygen. Right here in Bozeman, Montana, at 4,800 feet, we're probably around 20% or so, a little bit less. But we get up to base camp, which is about 50% of what you have, and then the summit of Everest, you have 30% of the oxygen. So 70% of the oxygen that we have here is gone. And so we can see what it was like climbing in the 1920s. They had felt hat, they had welder's goggles, their ice axes were about 3 feet tall. tall, which is pretty amazing. And this is sort of the climbing as they went up towards the summit of Mount Everest there. The climbers departing from their high camp. And this is how they communicated back in the day, was with letters. And they would share the letter back and forth to each other, and they would take a note like you do here. Nowadays, we'll have a radio set up at base camp. So when Dave and I are on the mountain, we'll be able to communicate with Travis and say, hey, we need some more oatmeal at camp too. Or more interesting, we found this great outcrop of rock, and you wouldn't believe the sample of rock that we have here, and we're really excited about it. And Travis will update that to the website in the for the students and say, look at this. This is some great science that we have there. Looking again up towards the summit of Mount Everest, you can see the strata there, which is layered, and the very top of our planet. And this view here is seen from the north side. You can really illustrate it very well. You've got the shale, and then you have the yellow band, obviously a yellow, and then the summit pyramid there, which is really has been seldom studied. Walking up towards the summit, this was May 17th, 1999. My climbing partner Dave going up the final steps there. And you can see just on the left-hand side of the summit cornice there are a few pieces of what look like rope hanging there. And those are little trinkets and things that climbers have left on the summit. And as the winds carry the snow over, it pushes them over onto the lee side. So this is the area that Dave and I hopefully will get to, and we'll be able to study it and have a look at it. And of course, when we're there, there's going to be plenty of opportunity. This is Ama Dablam, one of the mountains that we'll be going to study. We've got time-lapse cameras there observing the glacier to see how it's changing. Every half hour, a photograph is taken, and then we stitch those together so you can see in sort of YouTube time how fast the glaciers are moving. Pretty amazing stuff. So this is the equivalent of the goat that wanders around in the Himalayas. They're really beautiful mountain there. So the big challenge that we have as humans is that we have an ever-increasing population and ever-decreasing amount of resources. And we're tool users, obviously. That's why we have bicycles, pens, computers, automobiles, spaceships, all these things. And we need to figure out the next set of tools that's going to kind of merge those two lines of population and energy going in two different ways. And we're putting the burden is on you guys. That's why you have to do your homework at night and come to school motivated and prepared to learn about more cool things, because it's your future that's at stake here. Here's an example. This is Namche Bazaar, which is the village that we'll be hiking up through. This was a photograph taken in 1963. And we take a look at this picture here, which was taken probably 4 or 5 years ago. It'll have grown even since then. So you can imagine this village where there's no automobiles, everything's carried up on the back of a yak and then hand-built, and so you can see the amount of change there. Population density in Asia and India, the amount of people per square kilometer is far much more than what we have here in Montana. We barely just made 1 million people, and we're the 4th largest state in the United States. So you can imagine, and you're in a country of Nepal, which is about the size of, say, you've got 27 million people there. So the effect on the resource is quite dramatic. One notably being deforestation. Here we have a woodcutter carrying the wood in and out of the national park. And then here on the Tibetan Plateau, carrying timber for miles and miles from where that can be harvested on the back of people. And we're all part of this challenge. So one of the things that we'll be studying about the Himalayas is that there's over 8,000 glaciers there, and it's referred to as the water tower of Asia. And it is the source of 5 of the world's greatest rivers and the 5th of the water from the Himalayas. So just as we have Glacier National Park, which feeds the Missouri and the Columbia rivers, and we have our source waters here, we have the same challenges over there. Some of the glaciers in the Himalayas. And then this here is an example of the Gangotri Glacier, and this is at the terminus of the glacier where a river comes out. And this is a glacier that's about 30 miles long, about 50 kilometers long, and it's receding at a pretty rapid rate. And by going there and studying it, we can then put these into modeling, and we can then understand what's going on. And talking to this man here, he's in his 80s, and he was one of the first climbers in this region. He picked up a camera and he took pictures of all the beautiful things he saw there, but he didn't realize at the time that he was getting information about the glaciers that we can come back, and by doing historical repeat photography, we can see how much the glaciers have shrunk. It ends up being very valuable information. And the challenges with it, with the melting glaciers, we see here a swollen river. This is the Ganges River in a monsoon stage. So we're going to have an increased melt-off for a period of years, then followed by drought. So all of these are great questions that all of us need to answer and to understand. Mentioned earlier, low latitude and high altitude. Altitude is your distance above sea level. Latitude is your distance away from the equator. We're at about 45 and change right here. If you drive down to Yellowstone, you go through Gardner, you get to see that great marker that says 45 degrees north, and between the equator and the North Pole. The Himalayas, where we'll be climbing Mount Everest, is about 29 degrees away from the equator. So that's about like Florida. But yet the mountains go all the way up to 29,000 feet. That's why we have these the glaciers there. One of the challenges that scientists are looking at are glacial lake outburst floods, or GLOF, and this is where you have the glaciers up high here melting down, and they form up in a natural dam that's been created by the terminal and lateral moraines of a receding glacier, and it fills up, and then it gets to a point where it'll either release sort of slowly as it breaches the dam, or it could have a catastrophic event where you have this massive flood that would then go down valley. And this is looking up from high elevation, looking down the Dudkosi Valley. And each one of those valleys and one of those areas in there is home to many hundreds of thousands of people. And should the water go flooding out of there, it creates a real challenge. And we can see here, looking at this river, that this is in low water, and naturally it'll flood up to that sort of that bathtub ring there once or twice a year, and it scours the rocks, all the lichen is pulled off, plants can't grow. So we know that that's there. But by using science and earth sciences and geology, we can walk up and down that river embankment, and we can understand when the last time there was a major flood. And this is what we do in earth planning, to find out where floodplains are. How often does a big flood come through? And these are all great branches in the tree of science that are there for all of you to explore. But when floods happen, and they do happen in the Himalayas because it's a very active mountain range, and just as we had flooding here last spring from the heavy snowpack, it affects human life, oftentimes taking vehicles. This is a four-wheel drive truck that's just been crushed like a little, like a Lego car or something like that. So it's kind of a real challenge on there. So the glaciers that are formed in the Himalayas are a result of avalanches. So you can imagine it's this 8,000 meter tall fence. The snow comes up, it sticks to the mountains, it gets to a point where the carrying capacity is too much. The snow loses cohesion, it drops, and then it forms the glacier. Very much different than glaciers in Antarctica or up in Alaska, where you have snow that lands and then lands and then lands and compresses it down. So it's a different type of glaciers there. And delving into this, we'll learn more about them. We'll be able to share this information with all of you when you're there. So who likes mountains? Pretty much everyone, because we live in a mountain. Now, isn't that like crazy mountains right there? I mean, I see that and I'm like, yeah, let's go. So that's what I like to go do. But these are ice avalanches, and this is how glaciers are formed in the Himalayas. And they'll build up on this big snow, and they'll drop down. And the same technique is what forms the glaciers in Glacier National Park, because you have this snow fence coming that gets the main amount of snow coming from one direction to another, and it lands on it. A big thing there. Wind transport is another way of snow getting moved around. The monsoon and the jet stream, which is something that we'll be able to study because it's something we need to know about. If the jet stream's coming in, it'll be so windy we can't climb. But if the monsoon comes in, it'll be too stormy and too wet. And there's this little 2 to 3 week window in there that we can work with, and we have to figure that out. So we'll have a meteorological site that will be tracking the weather, and this news is we'll be sharing it with you in your classroom so you can get an idea as things are changing what is going on there. Looking down from up high on the mountain, looking beautiful. So sort of what the scientists are looking at in terms of glaciers in the Himalayas, that the glacier outburst floods will have greater amount of river water followed by drought, and then that's also affecting the structural integrity of the mountains. So this is a group of us that went to India to study the Gangotri Glacier, and this is at a tree farm, and the woman in the blue training jacket is she's a university professor. On her time, she's a tree plantation up in this high region because she realizes that planting trees is a good way to address the issues of all that we have going there. So this is the end of the show. We're going to pass it over to Dave, who has, this is a Yeti. Does everyone believe in the Yeti?
Yes.
Yes, maybe so. Okay. Well, we have a Tintin cartoon of the Yeti, but the Yeti is, it's one of these great folklores, and it ends up being that the Yeti is a bear. It's white, the Incredible Snowman. But it's a great story, but unfortunately it's fiction, so until proven otherwise. But it's most of the time when the Yeti comes through, what it was is that it was bears. And bears, when you have a bear standing up, they look just like a human, and their footprints just very similar. And so it's one of these, when the people that would live up in the high mountains and bears would come down and raid their sheep, they were always like, well, it's the Yeti. So, but we like that because it's a good bit of humor. So, Dave, should we go on to the science kits?